You learn already glycogenolysis, but today lecture of glycolysis is really make clear to understand is glycogenolysis. So glycolysis occurs in cytoplasm, in not mitochondria, glycolysis. And chemical structure of glucose, this is important. Because glycolysis break down glucose is right. So glucose in blood circulation, it should be very stable. So it can go another places, right? But the problem is in the tissue. If glucose molecule is very stable, it can hurt our tissue. Is right? So we should make less this glucose molecule less stable. So how can we do that? Is adding inorganic phosphate. Another terminology is charging. Charging this molecule is make less stable. So add inorganic phosphate. Class, did you remember glycogenolysis? Is first what we should do is glycogen as a substrate. We need inorganic phosphate. Is right? We must add it together. Did you remember? But that inorganic phosphate from ATP hydrolysis during relatively high exercise intensity. But this case, based on our glycogenolysis lecture, glycolysis is relatively low exercise intensity, right? So how can we add this inorganic phosphate to our glucose molecule? Let's see here, glucose molecule. This is first carbon site 1, 2, 3, 4, 5, 6. This is 6 carbon. So we must add inorganic phosphate. So it become glucose 6-phosphate. How about class? It's 6 mean it's carbon 6 is right. So it means inorganic phosphate attached here. This is why we call glucose 6-phosphate. And it's not anymore glucose because it charged molecule. So cannot go out of the muscle fiber into the blood. No, it just stay in muscle. Is right. And which one does is a hexokinesis. This enzyme do that. And inorganic phosphate from ATP. So we must break down ATP and we can get inorganic phosphate. Add this inorganic phosphate to the glucose molecule. It actually is a carbon 6 site. So we have glucose 6-phosphate. Is right. So glucose molecule is really stable. And right now is less stable. Important thing is, yes, we use 1 ATP. So glycogenolysis used inorganic phosphate from ATP hydrolysis. However, when glycolysis is from glucose to glucose 6-phosphate, we need ATP, 1 ATP. So based on this understanding, glycogenolysis can save 1 ATP. How about class? Does it make sense? And this is a chemical structure. Class, this is chemical structure. Do not really surprise, right? So I put this chemical structure, right, is for your understanding. So I let like a test like this kind of chemistry thing. Do not worry about it. But it's really help you to understand the whole mechanism, and as well as there are no undergraduate level exercise physiology have this kind of chemical structure. They do not have. Their experience is really low level. So I believe it is really good for you to study, and as well as after your graduation, whenever you need like reference, you can come back to this PowerPoint. So does it make sense? Doesn't make sense? So please watch here. Why this is important? Please here. See, this is glucose molecule, right? So carbon 1, 2, 3, 4, 5, 6, right? And this ATP. And using hexokinase reaction, the last phosphate group or inorganic phosphate go to the carbon 6 site. Carbon 6 site is right. This inorganic phosphate. So this is why we call glucose 6-phosphate. Does it make sense? And ATP is right now only 2-phosphate. So ADP is right. And we have the product is a proton 2. Oh, so it means glycogenolysis use inorganic phosphate from ATP hydrolysis, but glycolysis use ATP from our ATP. So because we break down ATP, it releases proton. So glucose has kind of like a disadvantage. We need one ATP and we release proton. It's potentially it can decrease our pH level and finally make metabolic acidosis, right? So glycogenolysis is better than glycolysis. It's comparing the ATP number as well as metabolic acidosis. Step 2 is just little arrangement. Glucose 6-phosphate can become fructose 6-phosphate, but it's reversible. So phosphoglucose isomerase reaction is a glucose 6-phosphate is converted to an isomer, is meaning another molecule that has the same chemical formula, which in this case of fructose 6-phosphate. This is reversible. And step 3, this is really important. Class, did you remember what is the key enzyme of glycolysis? That is phosphofructokinases, but our class is abbreviation is totally acceptable. PFK is PFK. So this step 3 is governed by PFK, controlled by PFK. PFK is rate limiting enzyme, a gatekeeper or regulator. This is important. How about class C here? Glucose become glucose 6-phosphate. It consume ATP, so it's just one direction. But glucose 6-phosphate, fructose 6-phosphate is reversible. But if there are demand and PFK is activated, and PFK, right, phosphofructokinases, it really push this reaction to the pyruvate. So this is really important enzyme and the step 3. And at the same time, because this glucose molecule is right now has only one phosphate group, is right? Yeah, phosphate group, yeah. And PFK add another inorganic phosphate. How to break down our ATP and put the inorganic phosphate or phosphate group to the fructose 6-phosphate and finally become fructose 1,6 bisphosphate. So this case, this molecule has two phosphate group or inorganic phosphate, is right? So it's really unstable. Actually, it's good, is right? What is the glycolysis? It's break down glucose, is right? So we need make less stable. So fructose does that. So this chemical structure and chemical explanation using the chemistry. So fructose 6-phosphate, yeah, is carbon 6 side is the phosphate group, is right, and another ATP. We should break another ATP. So last phosphate group go to the carbon first site of fructose 6-phosphate. So right now this molecule is a phosphorylated carbon 1 as well as carbon 6. So this is why we call fructose 1,6. And how many phosphate? 2. So bis phosphate. Sometimes di or sometimes just bi. So bis, bi, di phosphate. So our case is bis phosphate. And the last another product is rest product is ADP as well as proton. So again, yeah, why we call it like this? Fructose 1,6 bisphosphate is phosphorylated on both carbon 1 side and carbon 6 side. So I think it makes sense, right? Fructose 1,6 bisphosphate. So class is right now because PFK add another phosphate group. So left side or right side, like this fructose 1,6 bisphosphate is left phosphate, right phosphate is really less stable, right? So at that time we have metabolic seizure, aldolase. This aldolase cut this molecule, this 6 carbon molecule. So if we cut 6 carbon molecule, it means right now we have 3 carbon molecule and 3 carbon molecule. Does it make sense? Doesn't make sense. So this is fructose 1,6 bisphosphate, but using aldolase we cut. So how about this is this one, this part. So this molecule is phosphorylated carbon one side, is right, but we call dihydroxyacetone phosphate. We use just abbreviation, so DHAP. And this molecule is a phosphorylated is a carbon 3. So glycerol aldehyde 3 phosphate. It doesn't make sense. We do not call glycerol aldehyde 1 phosphate. The name is dihydroxyacetone phosphate, DHAP. And glycerol aldehyde 3 phosphate abbreviation is totally okay. So G3P. Doesn't make sense. And step 5, because actually DHAP, G3P has same like a formula, right? So it is DHAP is not really stable, so it just automatically or quickly rearrange its structure, so it's become G3P. So finally we have 2 glycerol aldehyde 3 phosphate or G3P. It doesn't make sense. So this is why we call glycolysis. Start one glucose molecule, and right now after step 5 we have 2 G3Ps, right? This is why you call glycolysis. Class, step 6, this is the most important step as well as the very busy step. And I believe it is for our exam, for our quiz, you must memorize all step and molecule and enzyme name. But how about after graduation? You do not need to memorize all of them. But still, after graduation, still you should know step 6 of glycolysis. This is really, really important. But how about class? Actually, I forgot to mention about it. Did you remember phosphagen system? Phosphagen system is release AMP. Did you remember, right? A2 ADP become AMP and ATP. That AMP activate phosphorylasis of glycogenolysis, and AMP activate which one? Yes, PFK. Does it make sense? So this is why AMP activate glycogenolysis as well as glycolysis. How can we say that? Because AMP activate phosphorylasis of glycogenolysis, and AMP activate here this PFK, because PFK is most important enzyme of glycolysis, but AMP can activate PFK. So this is important part. And step 6, so step 5, we have 2G3P, is right? And step 6, this is really, really important. And step 6, actually G3P release 2 proton. Class, I said 2 proton, but you should know there are 2 electron also. Did you remember? We have a lecture about chemistry check. 2 proton release and 2 electron release at the same time. And another one, did you remember chemistry check? If there are proton and electron, we need which one? Class, did you remember? We need which one? Metabolic Uber taxi is right. Metabolic Uber taxi to come to get proton and to get electron and reduced is right. Reduce. And G3P oxidize, right? To release 2 proton and 2 electron. Class, does it make sense? Doesn't make sense. This is important, and this coenzyme during glycolysis is NAD+. So NAD+ to come as a metabolic Uber taxi to getting 2 proton and 2 electron. Class, does it make sense? So actually this metabolic taxi go to somewhere, is right? Can you guess go to where? Actually it go to the mitochondria, is right? but proton, electron cannot go there, so coenzyme to come and to get 2 proton, 2 electron and go to mitochondria. And another one, wow, this inorganic phosphate, so we should add another phosphate, another inorganic phosphate to the G3P molecule. So we have more phosphate. So can you guess why? Because to resynthesize ADP to ATP, we need more phosphate group, is right? Inorganic phosphate. So this is why we need inorganic phosphate. But actually, can you guess this inorganic phosphate from where? Wow, here. So during ATP hydrolysis, ADP proton inorganic phosphate as product of ATP hydrolysis at low level exercise intensity, intense exercise, it goes to the mitochondria, right? But how about relatively high exercise intensity? That case, inorganic phosphate accumulated, is right. This inorganic phosphate can be substrate part of glycogenolysis, as well as it can go to the step 6 of glycolysis. So it means if you stop exercise, so in our cytosol doesn't have any ADP proton inorganic phosphate, or if you have really developed mitochondria, so there are no accumulation of inorganic phosphate, it means step 6, no more inorganic phosphate, no more substrate. So glycolysis just stop. Doesn't need to continue. Class, doesn't make sense. Doesn't make sense. So is here. So glycerol aldehyde 3 phosphate, but I said is G3P is totally okay. So G3P. Actually, we have 2 G3Ps, right? But I just show is one G3P. Yes, and NAD plus our coenzyme is right. Is coenzyme, right? So glycerol 3 phosphate release 1 proton. And another one is inorganic phosphate release another proton. This is not phosphate group, this is inorganic phosphate, so it has proton. So 2 proton and 2 electron release doesn't make sense. So however, this NADH get a is a proton as well as electron, but I think it's too confuse you, but just here. So NADH get a hydrogen atom but proton. So this is why we call NADH plus proton, 1 proton. So NADH plus become NADH plus 1 proton. And this glycerol aldehyde 3 phosphate get another phosphate group, is right, from the inorganic phosphate from ATP hydrolysis. So there are 2 phosphate and carbon 1 side, carbon 3 side. So carbon 1 side, carbon 3 side. So 1, 3, bis, because 2 phosphate is right, 2 phosphoglycerate. So product is 1, 3, bis phosphoglycerate and NADH plus proton. Yes, finally ATP is reduced when phosphate is transferred to ADP. So before step 7, we just consume ATPs, right? Did you remember? Hexokinase reaction. We need ATP. Fructokinase, PFK reaction. We need ATP. So we add inorganic phosphate. So it's time to we produce ATPs, right? So step 7. Step 7. Did you remember step 6? Put another inorganic phosphate. So we have 1,3 bis phosphoglycerate. So this 3 carbon molecule has 2 phosphate. So we can get 1 phosphate group from this 1,3 bis phosphoglycerate and we can produce ATP. But we have a 2 pathways, right? So this is why we can produce 2 ATP. And this is chemical structure. See, 1,3 bis phosphoglycerate, 2 phosphate group. So one of the phosphate group go to the ADP. So ADP can become ATP. And 1,3 bis phosphoglycerate has only 1 phosphate. So it's become 3 phosphoglycerate. 3-mine is a carbon site 3 as phosphorylated, is right. And how can do that? Because we have phosphoglycerate kinase. This enzyme do that. Class, does it make sense? And step 8, this is very simple too. So 3-phosphoglycerate, it can be 2-phosphoglycerate, and 2-phosphoglycerate can be 3-phosphoglycerate. It's reversible, right? This just little arrangement. If we have a demand, this 3-phosphate glycerate phosphate group is go to the second carbon site. So 2-phosphoglycerate. So 3-phosphoglycerate mutase enzyme to do is become 2-phosphoglycerate. Just phosphate group move to the second site of carbon. And step 9, it release water and become phosphoenol pyruvate. So PP is PP. It release 2 water. So like this. So one proton and another OH, right? This ion is become water. Does it make sense? Become phosphoenol pyruvate. And the last step, step 10. So PP give another phosphate group, only phosphate group to the to the ADP. So produce ATP, but we have 2 pathway, so 2 ATP, and finally become pyruvate, the last product of glycolysis. It's like this. Phosphate group go to the ADP and become is a pyruvate as well as ATP. So glycolysis summary, net yield. So this is important part. So glycolysis net yield, I said net yield, not total yield. How about class, did you remember, is a hexokinase reaction, PFK reaction, consume 2 ATPs, right? But how about total glycolysis release 4 ATP? So net ATP is 2 ATP. Does it make sense? So the net yield 2 water, 2 ATP, 2 pyruvate, and 2 NADH plus proton. Actually 2 NADH plus 2 proton, right? 2 NADH plus proton. And this proton and 2 electron actually shuttle to the mitochondria, but we'll talk about this later. So net yield 2 water, 2 ATP, 2 pyruvate, 2 NADH plus 2 proton, or just 2 NADH plus proton. So one glucose molecule can become 2 pyruvate molecules, right? So this is a metabolic pathway. So if like oxygen present in the mitochondria because you are trained people, right? So that case, 2 pyruvate molecule go to the T-cell cycle and more oxidize. And 2 pyruvate molecule have a little oxygen present or high oxidation intensity, or if you are not trained, 2 pyruvate molecule become 2 lactate molecule. But we'll talk about this later. And 1 ATP use step 1, right? Hexokinases. 1 ATP use step 3 is a PFK reaction, right? And 2 NADH2 proton is produced at step 6, is right? And 2 ATP produced at step 7, and 2 ATP produced at step 10. So this is why net yield, because 2 ATP used, 4 ATP release, is right? So 2 ATP, 2 water, so water is here, 2 water and 2 NADH plus proton. 2 proton. The last 2 PowerPoint slide is about glossary word. One is phase 1 of glycolysis. Another one is phase 2 of glycolysis. I would like to post this one is our Canvas website too. So if you want the exact definition of the molecule, you can find. Thank you very much. Our quiz 5. So how about class C? If you do not watch video, you have a disadvantage. Quiz 5 is write out all the state of glycose and the net yield. But class, this is usually the quiz question. I have a face-to-face class, but right now it's online classes, right? So it's a little bit advantage to online student, but they have a disadvantage. Learn is like face-to-face. So I think it's fair. So a little bit much easier to take a quiz. Or I can say it's more convenient or more accessible. So you do not need to write out all the steps. But how about like this? First, you need memorize this metabolic pathway. But actually, I explained each step, so I believe it is not really difficult. If you just write down several times, but if you couldn't understand mechanism, you can go back to my PowerPoint slide as well as this video lecture, right? So this one. No, actually, it's very simple. It's very simple. And using this one, right? You can just turn on the you can just like a pause, and using the note, right? You can take a note and you can just write down. How about number one? What is number one? And how about number two? What does it mean, right? So could you see glucose using ATP hexokinase do that is right, does that right? And what is this? This is glucose 6-phosphate. Does it make sense? What does it mean two? It means ATP. Oh, this is 1 minus 1 ATP. Does it make sense? And glucose 6-phosphate is rearranged and fructose 6-phosphate is right. Fructose 6-phosphate become fructose 1,6-bisphosphate. Which enzyme? Key enzyme. PFK is right. And again, we use another ATP. So minus ATP. Negative 1 ATP is right. And fructose 1,6-bisphosphate is become glycerol-aldehyde 3-phosphate, but G3P and DHP. But DHP is not really stable, so it's become automatically G3P. Is right? G3P. Actually, if you understand, its answer is very in the question, is right? So G3P. And G3P release which one? 2 proton, 2 electron is right. So NAD plus become NADH plus proton. Did you remember? So NAD plus become NADH plus proton is right. And how about what is number 6? Number 6, that is inorganic phosphate. Inorganic phosphate, because we need to add more inorganic phosphate so we can produce more ATPs, right? So how about number 8? What is the number 8? Did you remember? And actually, you can use this one, phosphoglycerate. But how many? So how many carbon? So number 8, if we forgot this molecule name, but this molecule is same. So however, it has 2 phosphate group is right. So 1, 3, 2 bis phosphoglycerate. Doesn't make sense? Is right. And take out 1 phosphate group, so it's become 3 phosphoglycerate. Did you remember? But this 3 phosphoglycerate phosphate group moved to the second side, so become 2 phosphoglycerate. Is right. It release water, and release water become PP, and we can get the last phosphate group from the PP and become what is the last product? That is pyruvate. Pyruvate is right. Doesn't make sense. And you can answer it here is right, and you can write down net yield. Can I say 2 ATP? Not 4 ATP is right. 2 ATP because net. And 2 water, 2 NADH plus proton, and the last one is 2 pyruvate is right. So this is kind of glycolysis. But however, I really want to nice to you guys. So I would like to ask like this. But you know, this is the what is this online quiz. So it's kind of like a matching quiz. So it's much easier for you. But however, I really want you to study hard. So please, using this slide, please try and write down and fill in the blank several times, as many as possible when you are familiar with, and take our quiz 5.